Okay, I hope majority of audience are here, so we shall get started. We just have about 80 minutes left for the session. So to give a background about myself, I'm Azad and I have about 6+ years of experience into network security, and I'm with the network journey for quite some time. And today uh, it is going to be Palo Alto, and it's going to be a demo session regarding. I've decided to go through some of the um, topics, as in to start with. We'll be discussing on the packet flow, on how Palo Alto processes the traffic as it gets it in and lets out towards the outside interface of the device. And we'll be going through a couple of labs today to support on how the rest of the sessions would look like. So depending on how the time permits, I'll be going through a couple of labs, or we'll be going through one lab. So let's get started quickly. Yes, we will be getting the recordings later. It will be shared by the backend team to you people. So I'll be sharing my screen, and we shall get started with the packet flow, and then we can jump into a couple of labs. So can people see my screen? So can everyone see my screen here?
Yes.
Okay, cool. So I think we can start with a little introduction about people who have joined. Probably I'll give a few minutes to talk about the introduction of each individual. So anyone who can start with, who can volunteer, please, about your work experience, or why you are here, and what is expectation out of the course, so that I can get a brief background of you.
Hi, so I can start myself, 𝑭𝒊𝒓𝒂𝒍𝒍. So I am in the routing, switching, and the network security. Having around 10 years of experience in the routing, switching, and network security. So mostly with the Palo Altos and the Cisco ASs. Yeah.
Okay, cool.
Yeah.
Thank you.
Thank you.
Thank you, Pankaj. So anyone else who wanted to give a brief introduction about you?
Hi, this is Srinivas. I have over 15 years of experience in routing and switching, and I worked with Juniper router switches and firewalls, but Palo Alto is new to me, so I've joined this training session to get some information about Palo Alto.
Okay, great. So welcome again, and anyone else who wanted to give a brief before we start? Let's give it another minute and we shall get started, if anyone else is interested.
Hey, this is Jordi here, and I'm up for network security and routing part as well. So I have 12+ years of experience, and yeah, we plan to roll out to Palo Alto.
Mhm.
So sort of going through some experience on this. Yeah.
Okay, welcome again. Okay, cool. So as said, we can get started with what we have planned for today. So so you all have with what I know, with what few people spoke about as a brief, I understand people are having a background about networking, and this course is basically for people who have a basic knowledge on networking, on how routing works and how switching works. And the basic criteria is to know how the routing or switching or basic networking works, so that it would be comfortable to follow along with me of what I'm trying to say over here. So considering that we are way ahead and people have already fair enough experience on firewalls, routing and switching, so that should be fair enough. So to get started with, I have prepared a presentation on how the packet flow of Palo Alto would look like, and how the firewall processes the packet when it takes the traffic in and lets it out. So we're going to discuss on the process that happens in between these two occurrences, when the traffic comes in and when it goes outside. So we're gonna look into 4 stages. Before that, I would like to let you know Palo Alto, since people have announced here that they have worked with Juniper, they have worked with ASA and stuffs. So if you consider ASA processes a packet in terms of if you consider in terms of OSI, it processes the packet from layer 1 to layer 4, or let's say layer 2 to layer 4. In case of Palo Alto or any next generation firewall, in that case, it processes the packet up to layer 7. So it does deep level inspection. It goes up to application level to inspect the traffic. That's what is special about the next generation firewalls. So how Palo Alto is different from other next generation firewalls is what we're going to start with. So considering the stages, we have 4 stages in which Palo Alto processes the packet. We have Ingress, we have something called fast or slow path, depending on whether the firewall session is already present in the firewall, or it's going to be new traffic that firewall is going to see, considering there is no session for that specific pattern of traffic for that specific traffic. And it's going to do something called application identification through its signatures, and it's going to do content inspection if applicable, and it's going to egress the packet outside. So anytime if you are having any questions, you are free to stop me and ask right there. I think I'm sharing a wrong screen. Just give me a second. I am supposed to share a document. Do you all see any document here that I'm sharing?
No, you stopped.
No.
Yeah, now we can see.
Okay, I'm sorry about that. So this is supposed to be the presentation I should present. So I was using multiple screens and I messed it up. I'm sorry about it. So yeah, so as I was talking about the stages that Palo Alto goes through before it processes the packet, or while it processes the packet, it goes through 4 stages. And first one being ingress, that is something that it checks for the incoming IP address information. It checks for the layer 2 information. It checks for the port information that it has to reach to, and it is originating from the source and destination port. I mean, basically a 6-tuple terminology that we use in networking, if you are aware of. So what all we use in 6-tuple is, let's say, source IP, destination IP, MAC address. And since Palo Alto being a zone-based firewall, it will have a zone attached to, it should have a zone attached to each and every interface it possesses, irrespective of whether it is a layer 2 or layer 3 interface. So what zone it comes in. So these are all the information that it can by default collect, because the traffic is getting into this interface. If it is getting into a specific interface, it should have an IP address if it's a layer 3, and it should have a destination IP where it has to reach to, and it should have its source MAC address and the zone that is coming in from, source and destination port. So these are the information it collects. Basically, this is the main motto of the Palo Alto undergoing Ingress packet processing. It does something additional to this, which I will be for which I'll be using this nice little diagram that Palo Alto provides. So you can get this. I'll just paste you the link in the chat if you want to go through the link in future. Fine. So I have prepared this, and I used to go through Palo Alto documentation. So I have worked with Cisco, but I'm not a big fan of Cisco's documentation. If people who have vast experience in Cisco, the documentation would be quite vast, and it will be very difficult to follow along for a new beginner or someone. So, but it's not the case with Palo Alto. Palo Alto documentation is very straightforward. It's up to the point on what we are supposed to get. It's available right away in the Palo Alto documentation for free. So you don't have to go anywhere in search of any documentation or any steps regarding any configuration that you wanted to make. It is readily available in Palo Alto documentation, which I'll be sharing you over the course of the time we look at different topics. So coming along with the ingress processing, as I said, the Palo Alto receives the packet. It collects layer 3 ingress zone information and checks for layer 2, layer 3 processing error. So this is something which happens in any networking device or any L3 device. It checks for any error or any error in processing that happens in the background that all the hardware would process, and if it would let the packet in to do any feature that it possesses only if layer 2 or layer 3 processing error check passes. So if there is any error found, it will not process it. It will deny. It will discard the packet, like you see here. So it's not going to process the packet if we see any error. Moving forward, considering 99% of the cases, unless and until there is any problem with the physical connectivity, we will not see any error, or if we have done any misconfiguration on our layer 2 or layer 3, especially layer 3, if you're doing a dynamic routing protocol, there is not going to be an error. So moving forward, considering there is no error, it checks if the traffic is an IPsec traffic. So until here, it expects the traffic to be a normal layer 3. If it's an IPsec traffic, as we all know, in IPsec we have a data payload, and we have an encapsulation on top of it, which will be the tunnel IP, right? So the same L2 or L3 error checks is supposed to happen for the packet that is inside the IPsec packet, the actual payload. So we have the tunnel IP address, and if we, okay, let me zoom it. So, yep. So we have the tunnel IP, and if it is going to be a tunnel traffic, we are supposed to decrypt it, and Palo Alto will decrypt the traffic if it finds the traffic to be a tunnel traffic, and it does the processing again. So going down, if it doesn't find any error, it will again come down to this step. And it will see if firewall inspection is applicable. So what does this mean is, I'm sorry about okay, what does this mean is, it has a specific criteria where firewall will check for the inspection, if the inspection is applicable or not. So let's say if it's a layer 3 broadcast, the firewall will not inspect, and if it's a layer 3 broadcast, it will consider it as a flood, and it would probably drop the traffic or discard the traffic. So to know what is the consideration that Palo Alto is going to make if it has to inspect the packet or not, it is going to be available on this documentation. Let me show you. So this is again a knowledge base, and you have two documentation in Palo Alto basically. So if I have to say, you have something called knowledge base, which is actually created by Palo Alto TAC engineers or any engineer who works in Palo Alto most of the time. And another is a Palo Alto documentation, which is again like a Cisco documentation we have. So this is going to be the Palo Alto packet flow. Over here, all I wanted to show you is how the firewall session, if it has to be, just give me one sec. If the firewall inspection has to happen on the firewall or not. So on what criteria it chooses if the firewall inspection has to happen or not, it is based upon this. It is basic networking actually. If you look at this, if it is IPv4 unicast with this point-to-point processing, it is going to inspect and forward for layer 3 or layer 2 traffic. Virtual wire is again another concept of Palo Alto, which we'll be discussing later. Tap interface is for monitoring, like we have it in Cisco. It is if it is IPv4 multicast, if it's going to be an EAGRP or OSPF control plane traffic, it's going to inspect and forward. If it's going to be a layer 2 traffic, it'll be forwarding the traffic alone. It will not be it's not going to inspect the traffic. So like, if depending upon what type of packet is going to come in, and whether it's going to be a layer 3 or layer 2 or virtual wire, it will decide upon whether to drop or inspect or just forward the traffic. Right? Any questions so far? So with this, we are going to complete something called ingress stage. So the packet is just entering the firewall, and it's going to process 4 stages, which is ingress, fast path, slow path, content inspection, and application ID. So this is something called ingress. It's a very basic processing that happens on all the layer 3 network device, apart from this decryption stuff that is happening here. So if you have any questions, you can feel free to ask me, so before we can move forward.
Yeah, Azad, like we are talking about ingress, right? No, is it an inbound traffic or outbound traffic?
It is an inbound traffic. Let's say, let me show you the lab that I prepared.
Something which is coming from outside, right? From internet, or assume that something is coming from outside to the firewall, or from inside zone to the how it is like we had.
Yeah, I can explain you that. So basically, it can be anything. What both of which you told is right. So if you consider the firewall, so this is a lab we are going to look at in some time after the packet flow is done. So if you look at this firewall, you see there are multiple interfaces to it. So whichever direction the packet comes in, that is ingress.
Okay, cool. Thank you.
So it comes in from outside interface, doesn't matter. It's the ingress interface of that specific traffic flow. If it's come from the user inside, this is considered to be the inside network, and this is considered to be outside network. So from whichever direction it comes in, that's what we have to consider as ingress or egress. Yeah.
Yeah, cool. Thank you.
Okay, thanks. So minimizing it for now. So moving forward, we have something called fast and slow path. So what does this mean? So here, if we look at fast path, basically in these two sections here, the firewall is basically trying to form a session. That's the main agenda. And it's trying to do natting if applicable. And it is going to process the packet for application identification or content ID, depending upon the configuration we have. So I'll talk about these two when we come to this later. For now, talking about fast path. Fast path is something which firewall anyways have to come to this stage. If in case the firewall has the session already on it, let's say the traffic has already passed the same pattern of traffic has already passed the firewall, it will have a session, right? Let's say morning I'm accessing something and it has not timed out and I'm still accessing the same website. The session that's formed on the firewall will still remain, and the firewall is going to use the same session. So it's going to look up, do a lookup and see if there is a session on the firewall which is already present for the specific traffic. If it's a yes, it is going to continue with the fast path. It is not going to go to the slow path at all. Slow path is basically for creating a new session. Fast path is something which checks for a session that is already present. If it is present, it just follows along with the other steps, right? So considering we have a new packet coming into the firewall. So as I said, what it does is it will try to form a session. So to form a session, what it basically needs from the firewall's perspective is it needs a few other information, like it needs to know what is the outside zone, what is the outside interface it has to go out to. So let me write it down here. So it has to know. So ingress zone, we have already figured it out in the ingress process. So it needs to know what is the egress zone, egress interface, or IP, and etc. So apart from these two information, I think those 6 tuple information we collected in the ingress will give us all the information regarding the source of the traffic. So this is for the destination of the traffic, or this is for the egress traffic, which firewall has to decide. So to get this information, it will do a routing lookup. So that's what is mentioned here. If you see, get the egress interface, egress zone, VSS from the L3 route, and L2 FBD lookup, etc. So it collects a couple of information from the routing lookup. So basically, if we consider routing, firewall does when we do a routing, we'll let's say we create a static route. We'll mention the destination IP or destination network that we are going to go to, and we'll mention the interface that we are going to go out to. If it's going to be dynamic routing protocol, again, it is going to have the same information. So it is bare minimum, it's going to have the egress interface or zone. Forget about the zone, it's a Palo Alto term. So considering a normal L3 networking device, it's going to have an egress interface, IP address, and all such information when we are going to check the routing lookup. So it collects the basic information along with the zone from the forwarding lookup and comes down and it checks for the NAT lookup. So if let's say the source is A and it wants to go to destination C, if this specific traffic for this specific port is applicable for any NAT policy that is defined in the firewall. So if this specific traffic which is coming in is supposed to get NATed, which means if we have written a NAT policy for the specific traffic, it will just collect that information. It is not going to do any NATing over here. So it's just going to collect the NAT information. And there is a catch here where if the traffic is going to be a destination NAT, if the destination of the traffic is going to get NATed, it will do routing lookup again, because the security policy we will be writing for a destination NATed traffic is going to be a post NAT zone. So this is basically to find out what's the egress zone, if the egress zone is going to change or not. If I have to explain you, let me take the lab diagram again. And so what I said is it is basically going to check the NAT if the NAT is applicable. Let's consider it is applicable. Let's say the traffic is coming. Let's say this is a server that is present in our corporate network, and someone from outside is trying to access a server. So if the traffic, the destination is NATed, so let's say that whether the traffic is initiated from the server to go outside to collect some updates from update servers, or if someone is trying to access this server from outside towards this server. So either way, this server will be NATed. So when the destination NAT of this server will be applicable, anyone? If the server is accessed from outside. So only in that case, this becomes the destination, right? So basically on the firewall, we are NATing this server. And when someone accesses this server from outside, it becomes a destination, right? The source of the packet will be this user, and destination will be this specific server we are interested in. So when the traffic comes in, it is going to hit this Palo Alto firewall. And let's say we have NATed this IP, the private IP from A to public IP B. Can anyone tell me which IP the user outside who's trying to access this server will hit, considering A as a private IP, inside IP of the server, and B as the public IP of the server for the outside world? Anyone?
Definitely, it will hit on B.
Public IP outside.
Or internal IP.
Okay, I heard someone saying public IP. I think, yeah, it's going to hit the public IP here. So basically, yeah, anyone? Okay. Yeah, as you said, people coming from outside, that's the purpose of NAT, right? We are NATing the traffic because our private IP shouldn't be exposed. So we as a user from outside or uninterest zone or internet, public internet, we will be hitting the public IP of the server or whatever we are going to access. So while we hit the public IP, it's going to be the destination. Let's say it's 1.1.1.1. And it's going to get NATed to the private IP, somewhere in 10.1.1.1, something in private network zone. So when this happens, the firewall's basic behavior is to keep the post NATed zone. So let's say this is an inside zone that we have. So I said every interface will have a zone for Palo Alto. Ethernet 1x2 is outside and 1x1 is inside in this case. So when we see the traffic coming in, it's coming in from outside zone, right? You agree? And when it gets in, or when the traffic goes towards the other side, it goes to inside zone. So when we are doing a destination NAT, like in this case, the traffic gets NATed from 1.1.1.1 to 10.1.1.1 in this case. So while doing a destination NAT, the Palo Alto behavior is it changes the zone to the post NAT zone. So after the traffic is getting NATed, the IP will be 10.1.1.1. And the IP belongs to inside zone. But basically, when this user actually accesses this server, he accesses from his own public IP to the public IP of the server, which is an outside zone, right? So when we are not considering this, or Palo Alto is not considering this, we are going to write a rule saying outside zone to outside zone, whatever IP action allow. So this is what we're going to write, but this is not something Palo Alto will process. Palo Alto will basically consider for a specific destination NAT traffic, it will consider the post NAT zone as the destination zone. So here the traffic flow that we should write should be outside zone to inside zone traffic allow. Considering the IP that we have to choose, it's going to be pre-NAT IP. So this is the basic stuff we are supposed to understand for us to write anything, any security policy or NAT policy. Once this is understood, it's going to be a piece of cake for us to write down any security policy for any type of traffic that we are going to encounter. So any questions here? It's going to be a very important thing and a very simple thing to understand, but what I feel is most of the people get confused over here on how to write, or they just have a guess on how to write this security policy and then go on to make mistakes at the end. So I just wanted to make this clear. So I'm spending some time over here before we move on to the next. So this is specific. Don't get confused about source NAT here. So when someone is someone from inside is trying to access anything on the internet, it's going to be a source NAT. So basically we are going to NAT our private subnet to NAT to our ISP's interface or ISP's subnet or whatever. So over here, it's going to be a very straightforward NAT rule that we're going to write. Insert inside zone to outside zone, IP address of the user to IP address of the server we are going to access, allow or deny. So this is something very basic, very straightforward and very common stuff that we do on all the devices. Maybe FortiGate might have something else. So I'm talking about the destination NAT traffic. If the NAT is applicable for the destination that we are going to reach or the user is going to reach, it's going to choose the post NATed zone and pre-NATed IP. It's clear? Or do you have any questions?
Yeah, destination NAT, we do it for the particular host, right? Which resides inside our LAN.
Yeah, but the common scenario is that. Yeah, common scenario is that, yes.
Okay, when the source NAT would be like from inside to outside. Now accessing internet from inside to outside, that would be the source NAT.
Yeah, here I'm not trying to talk about the NAT in general. I'm trying to talk about how the firewall processes the packet if it sees a destination NAT in the matched rule. So let's say the traffic is from a user in outside internet. Let's say we are trying, we are on our home network and we are trying to access. We can trying to connect Cisco and Connect from our office network to our office network. So we are going to hit our public IP of our ASA firewall or whatever, right? So if that in that case, if it's a Palo Alto, and if there is someone, if there's an engineer who's not aware of this one, he's going to write that the zone that user's traffic is going to come in will be outside zone because we are in internet, and he's going to hit a public IP of ASA or a public IP of Palo Alto, and that is also in layman terms, it is looking at from the outside, it is outside zone. But Palo Alto processes it in a different way, that if it's a destination NAT, the destination zone will be the post NATed zone. So after the traffic is NATed for the destination, it is going to be the private IP of the server, right? We are going to access the public IP and it's going to get NATed to the private IP of the server. So this private IP, whichever zone this private IP is in, that's the zone we are going to use in the security policy.
Oh, okay, cool.
Yeah,
thank you.
So to figure out that zone, we are doing a routing lookup again. So by doing that, we'll be coming to know what is the egress again, and what is the egress zone again, what is the egress interface that going to go out again, right? Yeah. Without doing this, we'll again going to assume outside to outside. We are not going to get the correct zone or the correct egress interface. So that's the main thing about this. So moving forward. So it does a NAT lookup, as I said. And
what if it's not a natted one? The destination, there's no natting.
it is going to ignore and move forward. It move forward to the next step. So that's the case here. There are so many if or else. If the condition is false, it's going to move down to the next step. If it is true, it's going to do what is mentioned. So here, if NAT is not present, if there is no NAT, that's why they say if applicable. So if the NAT is applicable, it does this. If it is not applicable, it's going to move on to the next step that we're going to see. So coming down, again, it's going to check the security policy with what are all the information we have. So if I have to provide you an overview of how a security policy would look like before we get into this, I have the Palo Alto turned on already so that we don't waste time during our lab. We can just kickstart it. I just have a security policy tab here. So this is how a Palo Alto would look like. So this is the security policy tab, and if you see what are all the information we have, or we get to configure on the security policy section. We get to configure the source. Under source, we configure source zone, source address, and if there is a user mapping, we filter the traffic using user ID that is mapped with the AD, and destination zone, destination address, application, service, that is the port number. Application is the actual application signature that Palo Alto uses or has within its sandbox to identify which application the traffic hits, irrespective of the port number. So again, the service defines the actual port number, source or destination port that we picked up from the ingress process, and the action. And this is the profile that we use for inspection, content inspection, antivirus, anti-spyware, and everything. So we have all these options that is available. So out of this, if you just try to understand how many we have already collected, we have collected source zone, source address. We can ignore the user for now, considering there is no filtering done using the user ID. Destination zone, destination address. So we have all this information. And do we have application at the moment? Do we see anywhere that Palo Alto has figured out the application until the time we have gone through the packet processing? No. So this is unknown as of now. And service is the port number. So we let's say the traffic is initiated from the user's side, and it's going to be a random port that the user would choose, or the PC would choose. And let's say the traffic is for port 80. So we have source and destination port number here. Yeah.
I have this one is I have a quick questions regarding this.
Yes. Yeah.
So if there is on the like a remote side, if there is a SD-WAN, the SD-WAN is work with the firewalls and the router both in SD-WAN, right? So
yeah.
If we have a branch firewall, so we build a policy like to communicate with the headquarters. So
Okay.
all the traffic goes through the branch firewalls.
Okay.
So how we we don't create like a villain like a game. So we creating a zone-based policies.
Okay. So your question is
how we create that though?
First thing, may know who is there with the question, because I'm not able to hear you properly.
This is
it the same for others as well?
Yeah,
your voice is breaking a little bit.
Yeah, he's breaking. Yeah.
Hey, you hear me now?
Yeah. Clear now. Yes. So you were asking about a data center or a remote location and a firewall in the office location, branch location, and traffic passing through that firewall. And I didn't get it after
only.
that.
All the traffic goes through the branch firewalls.
Okay.
Whatever the firewall devices communicating traffic goes to their branch firewalls, but on remote side is SD-WAN side.
Okay.
So we don't have a firewall on remote side, but even though that's those devices are firewall devices, and traffic goes to the SD-WAN, SD-WAN to the branch firewalls and communicate to the data center.
Okay.
So, but we don't create like interfaces like SBI things in firewalls. So we create the zone base.
So your question is about creating interfaces. Yeah, we are supposed to create interfaces. As I said, any type of interface that we create, we are having a privilege to create all the variants of interfaces that we have in a router, in a basic router. For that interface, if we are deciding that this interface is going to go out, it has to have a zone here. So if you see the options that you have for the interface, you are supposed to have a zone. If you're not having a zone for the interface, it's just basically going to identify an interface with a name. So that's how I understand about a zone. So
Okay.
if you're talking about creating a sub interface, so right now none of the interfaces are up. So once a physical interface is brought up, I have an option to add a sub interface, and it can be a layer 3 or layer 2, depending upon how we configure. So the underlying point is you are supposed to have a zone, irrespective of whichever interface you decide the traffic should go out to. If you don't have a zone, the firewall will not even allow you to save the changes or commit it. It will give you an error when you try to commit. So you need to map the interface or to a zone. May it be a physical interface, or it can be a layer 2 sub interface or layer 3 sub interface, or a VLAN interface. You have all the options available. I'm just trying to explain you how the packet is going to get processed. Regarding interfaces, definitely we'll be covering it up in the later sections. I hope I'm able to answer your question.
Yes. All right. Thank you.
Yeah, thanks. Okay, so for now, we haven't figured out what the application is. So we are going to set the application as any here. Palo Alto is going to use the application section as any, and then does a firewall lookup. And with what information we have collected, if we see a rule match and if it's an allow, it processes down or it discards the packet. Clear till here? With this, we are ending the slow path. And if the traffic is allowed on the security policy with what all information we have collected, it's going to create a session. So I told you in the beginning that the motto of slow path is to create a session, and which is achieved now. After creating the session, it comes down to fast path to this step directly. Why do I get here all the time? Okay, so it comes down to this step. Over here, what it does is it basically checks for the session state. So talking about session state here, let me give you a small example. So let's say traffic from point A to point B is going through the firewall. When on any layer 3 device, so considering this as a Palo Alto firewall, if the traffic is a new traffic and if it's a TCP, can anyone tell me what would be the first packet that we would encounter on a TCP session?
SYN.
SYN packet.
Yeah, that's right. So it's going to be a SYN packet, and that's exactly what Palo Alto is going to expect. It is not about this scenario alone. In any scenario, there will be certain expectation of what the current state of the traffic is. So let's say it's an initial traffic and it expects a SYN, and let's say if the destination has sent a SYN-ACK, or the source has sent a SYN, and it is expecting a SYN-ACK from the destination, but it receives a data payload. So that's breaching the state of the packet. And again, in this case, it expects a SYN packet from the server. Let's say a server is trying to connect, or some outsider is trying to connect our server inside. Server will expect a SYN packet, but it is getting something else, and that's a breach of the session state. So in all these scenarios, the firewall, if it sees any malicious state of the traffic, or if it doesn't see any state of the traffic matching the active state, it's going to discard it. And it does one more thing. It does natting over here. So remember, you have a NAT lookup done here by the firewall, which is being implemented here, which means the NAT is done. NAT is actually happening over here on the firewall. Coming down, SSL proxy decryption. So let's say we are sending a traffic from point A to point B, and it is HTTPS or SSL traffic, any SSL traffic. So SSL is encrypted using certificates most of the time, and the content inside the certificate is absolutely necessary for Palo Alto to figure out what application is underlying on to the specific traffic. So to figure out what application is underneath, it is supposed to decrypt the SSL proxy, or it will identify this as a HTTPS application and it will forward. So if you feel the specific traffic have to be inspected, you are free to set up a decryption policy on the firewall, as you do here. So you are allowed to set up the specific source destination for a specific service. You are also allowed to say you can decrypt this traffic and inspect, else it will not. So that's what it does here. So it looks if the traffic is a SSL traffic, and if it checks if there is any rule for the traffic, for our traffic which is coming in, that matches the rule that is mentioned in the firewall under decryption. And if it says it has to decrypt the traffic, it does, else it moves on forward. And it will process the packet for application ID. So application ID is basically going to try and identify what application the firewall is going to, traffic is going to use, using its own way of identifying the application, which is signatures. So here we said it does a firewall lookup, and it keeps the application as any, because we don't know what the application is, which is going to be solved here or identified here. So when it comes to application ID, it first checks if the application override policy is having a match for the specific traffic. So what I mean by this is, as a developer, consider a developer developing a new application, and he might have a specific name for it, and he might have a specific port number that it should work on. So this is a customized application, and this application, as I said, if this application override is not happening here, it will go on to check the Palo Alto signatures, which is present in Palo Alto sandbox, public sandbox. If this is a new application developed by the developer, and this is not available, or this is not identified as an application in pattern-based application identification, that is the signature that Palo Alto uses, the traffic will identify the application as unknown. So in the traffic log, you will see unknown. So if you don't want this, and if you want this to be a legitimate application that firewall has to identify, so that this is not something from an outsider trying to access something from our corporate network or something, we do a policy, we create again a policy to match the specific application or specific name, source, or destination. Like if I have to show you again. So on the Palo Alto, you see something called application override here, and you create a policy which has a source zone, which zone it has to come in from, destination zone, protocol, application, port number, and the application name that you have created already. So if this is created, it will just directly look up this application override policy match, identify the application, and it does what? It goes down to the security lookup again, which is to see if the specific application is allowed as a part of the security rule. If it doesn't, it checks again for the signatures that Palo Alto has on its sandbox to know what application the traffic is in. Clear up to this point? You have any questions? Okay, considering there is no response, I'm moving forward. Or if anyone has any questions, you're free to ask me. And coming down, if there is no rule match, again, as it does every time, it discards the packet. If there is a rule match, it comes down, it goes to the content. Oops. It goes to the content inspection. So content inspection is again something that does a protocol decoding, content matching. Content matching, by word, what I mean is it does a whole lot of different things that we see here on the security profile. So it's basically, if you see the security policy section, you have something called profile here, right? You have something called profile here. So this is what we're going to talk about as an under content inspection. So what exactly it does in content inspection is it checks for checks the security policy to know if content inspection or security profile is configured or mapped to the security policy. In case if it does, it will check each and everything that we have done here. Let's say, for example, if you consider URL filtering, you will have a whole lot of URL categories available. Let's say music category, news, you have job search, you have low risk categories, malware categories. So you can decide upon what you should do with this if the category of the if the traffic matches this category, and you can set up certain criteria on what we should do with this URL category that we identify as a part of the traffic. And again, with the file blocking, you can block specific types of file. And not only you have an option to block, you also have an option to alert the user. That's when the user get a warning. Sometimes you get a warning instead of being denied completely. And there is something called wildfire. Wildfire is a threat detection mechanism that Palo Alto possesses, which we'll be seeing in great details in our upcoming sections. Data filtering. Data filtering, again, you Palo Alto identifies a specific pattern of data if configured. Let's say we are configuring this data pattern ID with this application, this file type, coming in this direction, whether it's upload or a download, threshold. So you decide upon what pattern let's say you see a pattern of traffic that's overloading your firewall or your network. You set up a data filtering and you go on to monitor that so that you identify where the traffic is coming from and all those sorts. Denial of service attack. If there is any UDP flood happening, SYN flood happening, ICMP flood. So for all those, you can set up threshold or alarm rate so that if that happens, you decide what to do. So enable this, block duration, maximum rate of connections that comes in. So for all this, you set up an action on this profile and you go ahead and choose the profile onto the security policy. So only if we have a profile here, it goes on to check this section, or else it will directly process on to packet forwarding. Right? Any questions until here? And before we move on to Egress, we also have one more thing here that it does. It also identifies the application has already been identified here on the application override policy match or pattern based application, as I told you. But let's say the user is accessing Facebook. So Palo Alto Firewall identifies initially this as a Facebook application, or initially it identifies as an SSL. We access Facebook through a certificate or a password, as you all know. So how the application transitions here is what I'm trying to say. So initially the traffic is identified as an SSL application, and then it goes down to identify as an Facebook application. And then inside Facebook, we have Facebook chat, we have video, we use the application as a part of Messenger. So with all this transition, finally, when the actual session is getting established or the actual traffic is going out, it is going to identify the end application, and it has to inspect that too in case if there is an application change, and it will check the security policy again here. If there is an application jump that happens while the content inspection is happening. And one more feature of Palo Alto, both a app ID and the content ID is done in a parallel manner. So that's what we say Palo Alto's architecture to be single pass parallel processing. So it does content inspection, it does application override policy match or application identification parallelly, so that we achieve packet processing in a faster way than other firewalls, since it happens in a parallel manner. And then coming down, the packet comes to egress stage, and it has already identified what's the egress interface after natting, what's the egress zone and everything. And it does QoS if there is any QoS mechanism that is configured. And if let's say fragmentation, by fragmentation what I mean is, let's say this is a Palo Alto firewall, and this is a router that it ends up, and the ISP connects here maybe. Let's consider. Let's say this interface of a router can't accept the traffic in a way that Palo Alto is going to process, which means the packet has to be fragmented down and then sent out to this interface, because this interface is a lower end interface, and it is not going to accept the traffic at once when the Palo Alto sends it out. So in that case, it is fragmented and sent it out in chunks. And initially we saw if the traffic is a tunnel traffic, we decrypt it, and Palo Alto is again responsible to encrypt the traffic again, and then does the packet forwarding process again, and then transmit it outside. So with this way, it does all this in seconds, and since it does all the processing in a parallel manner, this is going to happen very quickly in Palo Alto. And SP3 architecture is something invented by Palo Alto, and which is not available in any other firewalls, as I know. So considering all this, it might seem overloaded for you people, or it maybe not. I'm glad if it is not, which will bring us down to the lab. Before that, I'll give you a minute or two to ask me any questions if you have, or any thing that you don't understand which I have to repeat, so that we can move down to the lab that we have as a plan for today. You're free to post it in chat, or you can unmute and ask me if you have any questions.
Can this steps, we have many steps that's in depth as well. So can this be briefed into a chunks, like on a high level, so we can understand, okay, on this, after this happens. For example, like we have content inspection, and before that happens the session initiation, or sorry, the session establishment in case if it's required. So like that, do you have any slide that you can explain? Or?
Yeah, I did prepare a slide, but I thought I would do this in an interactive way. So I used.
Yeah. Anyway, we'll have to go through this, every one of us. That's for sure. But on a high level understanding, like.
Yeah, on a high level, if you want to see, there are simple 4 steps. Packet comes in, packet goes out. In between, it does fast or slow path, depending on whether the session is a new session or an old session. So if it's an old session, it goes with a fast path. It doesn't look at the slow path at all. If it's a new session, it considers slow path to make sure a session is created. So that's about these two.
Okay, that's too short. Yeah, that's too short though, but that's fine.
Yeah. So in between these two processes, it collects necessary information that it wants, like a 6 tuple terminology that I told, all the 6 parameters that it needs, and the egress zone that it needs, looking at the route so that it finds what the interface or zone it has to go out to, and looks up if there is an NAT policy for the traffic. And if it's a destination NAT, I give you a brief overview of how it works. And it looks up for the security policy for the traffic, and if the security policy matches, considering the application as any, because we haven't identified the application, we have it for later under application ID. And considering the rule matches yes, it comes down to install a session on the firewall and goes to fast path and does a decryption if we have configured a decryption policy for an ASSL traffic, and goes down to application identification. Here, if it's a custom application developed by the company themselves, it has to be mentioned, or the application will be considered as unknown by the Palo Alto firewall. Because if this is not matching, it has to go and check the Palo Alto servers for app ID signatures, and it's not going to match because if it's a new application developed by the developer of that organization. So if we are not going to define that application on the firewall, we are not going to Palo Alto is not going to identify it here as well. So once after identifying the application, it does the lookup again to know if the application is allowed, and does the content inspection and does the egress. So in short, if you have to say, it's just, yeah.
Is that the layer 7 inspection, the content inspection when we talk about?
Sorry, I didn't get your question.
Is that the layer 7 inspection?
Yeah, that is correct.
Okay.
So it's basically application identification and content ID. Both are supposed to be for layer 7 traffic, because here again it checks for the application pattern, which is protocol decoding. I told you about the application shift from SSL to Facebook chat to Facebook video or whatever. So it does the protocol decoding here to identify that, and it also matches the file type. If we have a file blocking profile on the firewall, it also tries to identify URL filtering. That all comes in layer 7. So here, and application identification, we are actually trying to identify the application and see if there is any threat, so we can block the user from accessing it or block anyone from outside to access the internal corporate. So basically it's about identifying the yeah.
Is there any IP spoofing that happens in any of these? What if the IP address is spoofed, and how does it identify that?
Okay. That's again another topic on wildfire. And we also have something called data filtering, and we have something called denial of service. And when you talk about IP spoofing, you can set up a data pattern here, where for a specific data, for a specific application, for a specific file type or a direction, if the traffic is coming in, we are allowed to have any allow or deny or alert the user. Depending on that, it will process the traffic if in case we have it in the security policy here as a profile.
Oh, that needs to be like customized, is it? It's not an intrinsic behavior of the firewall itself that
No,
does
it is.
the anticipation.
No,
Okay.
it is not. Yeah. Okay. So do we have any more questions, or we can move on to the lab?